Hi everyone. In this video, we're going to talk about expressions and how to interpret them. In the next video, we'll talk about how to simplify expressions. So the first thing that I want to point out is that expressions are not the same thing as equations. So equations have equal signs, and typically you solve equations. You're probably familiar with solving equations that have an x in them, and you're solving for x, and you're trying to manipulate the equation so that you get x alone, and so that it eventually says x equals some number. So those are equations. Expressions do not have an equal sign. So they're standalone terms, and you're not solving anything with them. You can simplify expressions, like we'll talk about in the next video, or you can interpret them in terms of real life situations, which is what we're going to do now. So in this lesson, we're going to go through a couple different examples here. These are tough. There's no particular way that I know of how to teach this. It comes with a lot of practice, but there is a strategy that I can show you for how I go about interpreting expressions. And the same strategy will work for interpreting equations, which we'll do in the future. Okay. So that's why we're just going to do a lot of different kinds of problems so that you can sort of see the strategy and how it plays out in different contexts. So let's look at number one. This says if there are X total undergraduates enrolled at Rowan and Y total undergraduates enrolled at Stockton, what does the expression Y minus X mean? Okay, so again, this is an expression because there's no equal sign. So this is a term, sitting by itself. It doesn't equal anything, but it does represent something. So what does that represent? And here is the strategy that I want you to write down in your notes. So the strategy for interpreting these things is choose numbers for the variables that make sense to you. Plug in those numbers and see if the answer that you get for the expression makes sense. Okay, so I don't know an easier way to kind of explain this strategy, but this is my strategy. Sometimes I do this quickly in my head. Other times I do it explicitly and I actually choose several examples and I write them out. So I'm going to do it explicitly for you, obviously. I'm going to choose some examples for X and some examples for Y. Now I see the expression here Y minus X, so I'm going to choose Y to be bigger than X, just so that I get a positive answer here. So notice what I'm doing there. I'm already doing some work because I'm going to choose specific numbers so that my answer to this expression, when I actually simplify it, makes sense, because to me a negative number wouldn't make sense. So let's assume, and now we're going to, do some assumptions in terms of the real life situation. So if we're thinking about students at Rowan University, how many students are there? I mean, let's just go with 15,000. I don't know how many students there are. I'd have to look that up, but that's a fair estimate for the number of students at a small college. And let's also assume that at Stockton University, which is where I work, let's assume that there's maybe 10,000 students at Stockton. Okay, if you assume that, then the expression Y minus X would be 15,000 minus 10,000, which would give us 5,000. And to me, now I am going to use my intuitive knowledge of this real world situation to understand what this 5,000 means. Now remember, these numbers, I just chose them to help me make sense of this answer right here. This is the important thing. You don't have to actually do you don't have to plug in real numbers to figure this out. This is just to help me make sense of what this expression here could mean. And it seems to me that the number of students at Rowan, there are 5,000 more students at Rowan than at Stockton, because there's more students at Rowan because this came. Oh, I already did this wrong. This says X total students at Rowan. See? So that's good to reread the problem as well. So I have to switch these. So let's assume, oh no, I don't have to switch them. I just interpreted it wrong. So it means that there are more students at Stockton because Y represents Stockton. So let's write that out because it's a good habit. Let's put Y is the number of undergraduates at Stockton. This is always a good habit to get into. Defining your variables. And X is the number of undergraduates at Rowan. There we go. Okay. Well, I knew something was wrong because what I was saying wasn't aligning with what I saw here for each thing. Okay, so X is the number of undergrads at Rowan. I'm just checking this. And Y is the number of undergraduates at Stockton. Okay, so then this means that at Stockton, we have more students than at Rowan, according to this expression. I don't know if that's true or not. But now I can interpret what this expression, the Y minus X, what does that mean? So we can put something like, thus, Y minus X represents the difference in undergraduate students between Stockton and Rowan. That's one way to say it. You might also say there are more students at Stockton according to this expression. And if you're taking notes, feel free to pause your video so that you can write this down. So this Y minus X, that's the difference in students. That's how many more students there are at Stockton compared to Rowan. So that's another way you could say this. So I'll just put another way to interpret this. This expression represents how many more students there are at Stockton compared to Rowan University. Something like that. Okay, so that was a kind of a long-winded way to explain the method I go through in my head for how to interpret this expression. So why don't you try, actually I'll do number 2 with you together and then I'll let you try 3 and 4 because this one says write an expression. So here we were given an expression and we interpreted it, and now we're being asked to write our own expression. So if it takes you T minutes to get to campus from your house, write an expression that represents the amount of time in minutes that it will take you to drive to campus and then back home. Okay, so again, my strategy is to plug in a number. So assume that T equals, let's just say 30. Maybe it takes you 30 minutes to get to campus. So how much time would it then take you if you went to campus and then you drove back home? Then it would take you 30 plus 30, which is 60 minutes to drive to campus and back home. So notice I didn't just put 60, I wrote out what I actually did to get that answer. And that will help me because I know that T is not actually 30. T can represent any number, which means instead of 30 plus 30, that's the same thing as T plus T. So the expression for how to get, whoops, pressing the wrong button here. For how long it takes you to drive to campus and then back would be T plus T. And if you want, you can simplify that to 2T. So there is the expression that represents how long it takes you to drive to campus and then back home. But notice the strategy. I plugged in a number so that I could make sense of what was going on in the problem. And then I just replaced that number with the variable, with T in this case. Now in some problems, there's more than one variable going on. So you might need to make a lot of assumptions about, the different numbers that could exist and make sense in that context. So let's look at 3. I'll let you try this on your own and then I'll go through it with you. So pause your video now. Think about this context and what this expression means. Okay, so if you drive R miles per hour for T minutes, so you're driving R miles per hour for T minutes, I already feel like this doesn't make sense. I feel like this should have said T hours. So let me change that. I'll change it in your work. So let me think about this. If you drive R miles per, so let's say, assume that I drive 60 miles per hour for 2 hours. Let's say it's like that. So what does it mean if I multiply those? Well, if I'm doing 60 miles every hour and I've done this for 2 hours, then if I multiply them, that would give me 120 miles. So let's write 60 times 2 that should give you 120 miles. So yes, this should have said hours, not minutes. If this said minutes, there should have been some kind of a factor of 60 in here, like dividing by 60 to convert, because these units have to be the same. So I apologize. So this should have said hours. Okay. So what does that expression mean? So the expression R times T means the total distance you drove. So that's what it's showing. And I use this example to help me to understand that that's what that expression is actually representing. Okay, let me read number 4, make sure that it makes sense. If the gas tank of your car can hold G gallons of gas and a gas station charges C dollars per gallon, write an expression representing how much it costs to fill your entire tank. Okay, so yes, this one makes sense. So pause your video now and try number 4. I'm going to use my strategy here. Assume my car can hold 13 gallons. I think that's about what my car holds. Maybe it's 15. And right now, as we all know, gas prices are horrendous. They're ridiculously high because of all the world events going on. So I think it's about $4.70. I have to buy premium gas because I have the best car in the world, which is a Subaru WRX. And it's got an exhaust on it and it's got a turbocharge, so it requires premium. So for simplicity, let's say gas costs $4. So assume my car can hold 13 gallons of gas and that gas costs $4. So, per gallon. So if I know I can hold 13 gallons and it costs $4 for every gallon, then if I multiply these two, this means it will cost, let's see, what is 13 times 4? 52? It will cost $52. Oops, pressed the wrong button there. $52 to fill up my tank. And notice I wrote out how I got that. That way I know that I can write the correct expression now. So it looks like you're multiplying instead of 13, we were substituting that in for G. So that really means your car holds G gallons. And we don't know exactly how much gas costs. Instead, we use this variable. So assuming gas costs C dollars, then to figure out the cost of filling your entire tank, you would just multiply G times C. This is also assuming that your gas tank is completely empty. So I should say that. Okay. So go ahead and try number 5. A TV series has a total duration of M minutes and has X total episodes. Write an expression representing the average time of one episode. So pause your video and try this now. Okay, so as I was sitting here thinking about this problem, I was thinking about Cobra Kai because it's one of my favorite TV series. And I think the total duration of one season of Cobra Kai is like 450 minutes, something like that. And I think it had 10 episodes. So I was sitting there thinking, you know, if it had a total of, so here we go, there's my strategy again. I just do it in my head quickly because I've had a lot of experience with these problems, but feel free to write out, you know, an example. Assume M equals 450. So that, remember, this is the total length of the series. And that there are 10 episodes. So we'll put X equals 10 episodes so that we remember that that's what X means. So how do you figure out the average time of one episode? One episode would then be 450 divided by 10 is about 45 minutes. Oops, I keep pressing the wrong episode. 45 minutes for one episode. And then we look back at how we did that. Let me move this up so we can have this all on the same line. So what did we do? We just ended up dividing the total minutes, which was 450, divided by the total amount of episodes. So one episode will be this long. It'll be M over X minutes long, something like that. You could also do a unit check. So you could check to make sure that the units match up. So in other words, in the top, the M, if that's the total duration of minutes, so then in the top that will be minutes. Let me see if I can write this up here. M minutes. And in the bottom, if you have X total episodes, so you can say X episodes, then your units for this whole thing is minutes per episode, minutes per one episode. And that's what you were asked to find. What's the average time of one episode? And so you can see this unit conversion here. I'm just doing some unit analysis, you might call it. That can help you to check to make sure your expression makes sense. The same thing up here, if we wanted to check to make sure this G times C makes sense, then you could write the units. So the units for G, which is the gallons that your tank holds, that would be gallons. Then you're multiplying that times dollars per, that means over, per gallon. So when you do that multiplication, you'll see that gallons divided by gallons crosses out, so you won't have gallons anymore, and you'll be left with dollars. So this whole thing, the units on that entire expression is dollars, which makes sense because the question was, how much does it cost to fill up your entire tank? So that unit, I'll leave that there in case you want to see what I did. That unit analysis, that's usually what I call it, can help you to confirm that the final units make sense. For example, if we got gallons as the final units here, that wouldn't make sense because the question was, how much does it cost? So if we did it correctly, this unit analysis, these other measures should cancel out so that we're only left with dollars. Okay. All right, so try number 6. You get paid D dollars per hour for working H hours per week. Write an expression representing your total weekly salary. You can try using my strategy of just making an assumption about what D and H represent and then thinking about what that means in terms of this context. Or if you don't need to do that, then you can just think about what would be the correct expression to represent your total weekly salary. So pause your video and try that now. Okay, so you get paid D dollars per hour. Assume D is 20. Or maybe we should go more realistic, 15. All right, assume you get $15 per hour, put it like that, and you work for, I don't know, 30 hours maybe? 30 hours per week. Okay, so if I make $15 every hour and I work 30 hours, then my total weekly salary, I would calculate that by doing 15 times 30. So 300 plus 60, so that'd be $360 for the week. And if you look at how I did that, so then in general, the total weekly salary, it looks like I did that by just multiplying. So D times H, that would be your total weekly salary in general, regardless of what D is and regardless of what H is. And that's the power of using variables, right? Is you can represent concepts such as your total weekly salary in general, no matter how much you get paid or how many hours you work. That's the whole purpose of using these variables so that we can represent these things in an abstract, general way. Okay, you could also do this unit analysis here. So we could check. So D is measured in dollars per, that means over, hours. And then you're multiplying that times H is hours per week, 30 hours per week. So look, your hours will end up canceling out. This is going to cancel. Can I put a strike through this? This is going to cancel with this hours down here, because hours divided by hours, they go away. So you're left with dollars per week, and that's what you should have because it's a total weekly salary. So it's dollars for every week. So that unit analysis there, that makes sense. Okay, I'll leave that there in case you want to add that to your notes so you can see what we're doing. Again, we're just using this analysis to check our work to make sure that the units that this should represent make sense. This doesn't mean that this is necessarily the correct answer, but it is further confirmation that it is likely the correct answer. If we got something that just said this equaled weeks, then we know that can't be right because your salary is measured in dollars or some kind of unit that measures money, like cents or pesos or something that measures money. Okay, so here's the last one. Again, this was just a bunch of different example problems so that you could get a feel for the strategy for interpreting expressions, but then you have to actually do a bunch of practice on your own interpreting expressions and writing expressions to help make this easier. So if X Xbox consoles and P PlayStation consoles are sold in one day at a specific store, and the Xbox consoles each cost $A, and the PlayStation consoles each cost $B, explain the following expression. Okay, why is it telling me that this is an error? Oh, okay. All right, so we'll do the first one together, and then I'll let you try B and C. So X times A. Well, there's X Xbox consoles, so let's assume that there are, I don't know, 10 Xbox consoles. 10 Xbox consoles. And let's assume that A, that's the cost of each one. Xboxes are expensive right now, so we'll go with $600. So that A equals $600. So if you multiply those, oh, and this is Xbox consoles sold in one day. It says right here, are sold in one day. Okay, so $600 for each Xbox. There we go. So I'm just making my assumptions here very clear for myself. Oh my gosh. So that, so it's easier to interpret what this expression means. So now if I multiply, if I assume those things, then I will know that X times A is 10 times 600, so that's like $6,000. And if we think about what that means, that looks like that's the total profit that this store made just selling Xboxes. So we can put thus, or therefore, X times A represents the total profit from selling Xbox consoles in one day. This is a daily thing because of what it says. Okay, so again, notice the strategy. I plugged in some numbers just to help me think about what this expression might mean. It's hard for me to just think in terms of letters here because I'm not really sure what the multiplication means. But as soon as I plug in numbers and I can think through this more intuitively, it makes sense to me if somebody has 10 Xboxes and they sell all of them and each one is $600. Now when you multiply, I can see that makes sense. That's the total amount of money you just made selling Xboxes. So that's why I do this that's why I use this strategy, because it helps me to take something that seemingly looks very abstract that I would have no idea how to interpret, put some concrete numbers on here so that now I do know how to interpret this number, and then return back to the abstract idea of what this means in general then, because it doesn't mean 6,000 because these are numbers I just made up. But it does mean the profit sold, the profit that you gain from selling Xbox consoles. So why don't you try part B and part C? Interpret these two expressions in the same context of this problem. Pause your video now. Okay, so because I did this problem, I don't actually have to write out this for part B, but I will. But once you do part A, part B makes way more sense, right? So this is the same idea, but for PlayStations. So let's assume that you could even change this if you want. Let's assume you sold 5 PlayStations. I'm hacking on PlayStation here because I'm an Xbox player. So it's got to be less. It's got to be less than Xbox. Okay. And then let's assume that B equals, I don't actually know how much PlayStations are. So we'll just leave that at 600. 600 for each PlayStation. So then when you multiply, you get $3,000. So that means P times B represents the total profit from selling PlayStation consoles in one day. And now that you know what each of these two expressions mean, that should make part C easier as well. So if you haven't tried part C, go ahead and pause your video now and try part C. And if you're ready, then if you take this expression, which is the profit from selling Xbox consoles, and you take this expression, which is the profit from selling PlayStation consoles, and you add them, then this whole expression represents the total profit made from selling both Xbox consoles and PlayStation consoles in one day. And so you can see how if you were just asked to think about what this is, my strategy would be to first break down what does this first term mean, and then what does the second term mean. So if you didn't have parts A and B here, if this is an assessment question, and you were just asked to interpret what this expression means in terms of this problem, I would do this same exact process. I just wouldn't have an answer for A and B because there wouldn't be questions there. But it is so important to learn how to decompress or decompose a bigger looking complicated expression into its smaller components and then interpret each one, and then you could think about what it means to add them all together or to subtract them or whatever operations are going on. So we took something that could look overwhelming when you first look at it, and we made it into something that seemingly is not so overwhelming by using concrete numbers here and then interpreting what the actual answer is in terms of a number. Okay, so that's it. There's extra practice posted down below. Again, this whole lesson we interpreted expressions. That's why there were no equal signs in any of the things that we were interpreting. In the next lesson, we're going to work through how to simplify expressions. So we're going to, instead of interpreting them, we're actually going to do some algebraic thinking and manipulating and simplifying expressions. And then after that, we're going to talk about equations. So just keep in mind that expressions are not the same thing as equations. So that way you're prepared to learn about equations when we get there in a few lessons.